All right, guys, we're going to start with problems 1 through 10. 1 through 5. Questions on 1 through 5 are one of these that y'all want to look at. Five. 1/5 to the x plus 2. So the first one we're going to do is 1/5 to the negative 2 plus 2. And then we're going to do 1/5 to the 3 plus 2. And we're going to evaluate both of these here. And I would just use the 30xs to do these. Don't need that extra. So 1/5 to the negative 2 plus 2, enter is 1. Number 5. And then we can say 1/5 to the 3 plus 2, which is 0.00032. Now here we have to really go 4 decimal places to round it, but all the ones on the test, if there is a decimal attached to it, go 3 places and round. If you're not sure and want to give me the entire decimal, that is fine too. So our two answers for this here are 1 and 0.00032. Rounding to 3 decimal places for number 5 for when x is 3 won't be helpful, because what would that be if we rounded to the 3rd decimal place? It'd just be 0.000. Yep. So this here we almost had to go 4 or 5 out, but that's it for that there. Any other questions on 1 through 5? We feel good with these here. Yeah. When you plug that value in for x, I'd go on and put it in parentheses and you just type it in like you see it. 6 through 9 are not on the test. Meant for them to be, but ended up putting the test together and then realized after the fact that they were not on the test. Log base b of y equals x if and only if b to the x is equal to y. We can say the same thing with natural logs. Natural log of y equals x if and only if b to the x is equal to y. Because we can do this by the switching type method. We can start off and look at number 12. Log base 9 of 6,561 equals 4. If we rewrote this as an exponential, this would be what? 9 to the 4th is equal to 6,561. Yeah. That's it. And we did this with inverses. We could say that we put both sides to the base of 9. We use 9 because of the base of the logarithm is 9. Because our 9 to the log base 9 would cancel, leaving us with the 6,561. The other side is 9 to the 4th. But that's it. Questions on number 12? What would number 13 be? 5 to the 7th equals 78,125. Because we're really putting both sides to the base of 5. Those would cancel. Giving us 5 to the 7th is equal to 78,125. How about number 14? 1/7 to the negative 4th power equals 2,401. Questions on these so far? Might as well go on and finish it out. Log base 15 of 15 equals 1. An exponential form would be 15 to the first is equal to 15. Now on these here, it would be good to write the first power, because again, we're just converting from one to the other. If we were solving for this here, we don't necessarily need the first power. Log base 15 of x equals 15. Then we don't have to write it, but here we do need that 1. Questions on 12 through 15? What would number 16 be? E to the 7 is equal to x. Because if we did like the last one, we would put both sides to the base of e, because e to the ln will simplify, mainly because even though it's not written, it's understood that our base is e to the ln of e. So they would simplify out, giving us just our x, because that's gone. And the other side is e to the 7th. So e to the 7th is equal to x. Even though it's not written with the ln, our natural log, the base is still e. What would 17 be? Yep, that's it. 18. And lastly, number 19. E to the 9th power equals x. Questions on how we change these to exponential form? Questions on this here? Good, Trina? Okay, just making sure. All right, let's look at the next set. Rewrite the equation in logarithmic form. So we're going from exponential to logarithmic. So what would 20 be? Log base 3 of 81 is equal to 4. We're doing exactly what we just did, but in the reverse order. Now, when we talked about inverses, really what we did at this point is we can apply log base 3 to both sides. And over here, our log base is 3 of 3 to the 4th. Well, log base 3 of 3 would simplify, leaving us with our 4. And the other side is just log base 3 of 81. And the reason we chose 3, well, the base was 3. How about the next one? Log base 1/5. Yeah, log base 1/5 of 1 over 125 is 3. What would our next one be? No. Log base 125 of 25 equals. Questions on how we got these 3 here? Now, if I wanted to check one of these, is I can grab the graphing calculator and do math. Log base of 125, base 125 of 25 is 0.6 repeated, which is 2/3, which is exactly as we had it written, yes? So that's a way to check these. But the only time we can check them is if the base, the number inside, and what it's equal to are all numbers. We don't have variables. Let's look at 23. E to the 4th equals x. What would this be? ln of x is equal to, yeah, ln of x equals 4. Just like we said on the ones before, really we can just apply the ln of both sides. Well, ln of x stays ln of x. ln of e is 1, which really just simplifies, well, ln of e to the 4th simplifies to just 4, leaving us with ln of x is equal to 4. Now, unlike the last 3 that we did, we can't check this one because we don't have a value of x. X has to have a specific value. 24 would be what? ln of 27 is equal to y. And lastly, ln of y equals x. 25 is actually kind of nice. And then what we had is the general form. E to the x equals y if and only if ln of y equals x. But questions on rewriting from exponential to logarithmic, or logarithmic to exponential. 26 to 31. Evaluate each logarithm and round to 3 places. So for these first 3, we can use the graphing calculator and go math. Log base 5 of, again for a fraction, alpha y equals enter, 1 over 125 is -3. Alpha y equals enter. Now, does this answer have a decimal place at all? No, so we don't have to round to 3 decimal places. Only round if there's decimal places. Let's look at the next one. Log base 9 of 2,187. So we go math. Log base 9 of 2187. 3.5. So this one does have a decimal, yes? Do we need to round it to 3 decimal places? It doesn't have it. We could. It would just be 3.500. But 3.5. Well, while we're at it, let's do 28. Math. Log base 10. 0.1234. 1 is -5. These are the same, but that's because our log button, the base is understood to be 10. So if the base is 10, we could have just hit log. We didn't have to do the log base. $29, $30, $31. Both calculators have an LN button. 3.296. This one does have more than 3 decimal places, so we'll round it to the nearest 3rd decimal place. If you're not sure with it, give me more spots. That's not going to hurt you. And with most of these here, I would type it in exactly as you see it. ln of 2 over 7. I wouldn't replace a single thing. I wouldn't replace a single parenthesis or whatever the numbers is. Just type it in as it shows up and let the calculator do it. Negative 1.253. Negative 1.253. And lastly, we can look at 31. ln of 4 to the 6th, 8.318. that's it. It'll be Thursday. Mm-hmm. Questions on 26 through 31. Expanding. We want to expand the logarithm. Quotient. Our division properties first, and then product, and then our power property. Quotient, product, power is the order we do these in. Which one of these do we want to look at? 34. 7x, the natural log of 7x to the third over 16y squared. Well, we do have a quotient, we have a division. And whenever we have a division, we rewrite it as the natural log of the top minus the natural log of the bottom. Natural log of the top, our logarithm of the top, minus the logarithm of the bottom. Now our product property is next. Product property states that whenever we have two or more things multiplied inside the log, we can rewrite it as addition. We do indeed have that there. It'd be the natural log of 7 plus the natural log of x to the third. Minus. Over here, ln of 16y squared, we'd have the natural log of 16 plus natural log of y squared. But we would have to put the second set in parentheses if we did this as we were supposed to, or as we're supposed to in each step. But anything that's in the bottom of the fraction, anything here in the bottom of the fraction, its signs, when we're all done, are both going to be negative. Since we have two terms in the denominator, both of those terms, logarithms, are going to be negative. So we're going to have negative with our ln of 16 and negative with our ln of y squared. Now we could have just applied that as we were breaking it up, since we know the minus is in front of it and they're supposed to both be in the bottom. They would both be just negative. Or we can put the parentheses and then apply it through. Either way works. But the last thing we have is our powers. And we would move the exponents to the front. Now it's going to stay ln of 7 plus our ln of x to the third is now going to be 3 ln of minus ln of 16. We'd move the 2 out front, giving us 2 ln of y. And that's it. Questions on number 34? All right. We good to move on to 33. Log 7x squared over y cubed z squared. Again, we have a quotient. So our quotient product property says that we can take log of the top minus log of the bottom. Now in all these here, there's not a specific base written. It's understood to be 10, so we can just write it as log. If there was a base, we'd fill it in. Product, huh? So it'd be log of 7. Yes, plus log of x squared minus log of third minus log of z squared. So we didn't have to do the parentheses and distribute through. We just know because both of the y to the third and z squared are in the bottom of the fraction to start with, they both have to have a minus in front. Power property. Well, log of 7 is still log of 7. The 2 is going to move to the front, telling us plus 2 log of x. Minus the 3 would move to the front, telling us we have minus 3 log of y. Move the 2 in front. The last one, minus 2 log of z. Questions on 32 through 35. We feel good with these here.
35 would just be natural log of 8 plus natural log of x to the third. And then when we do when we do powers.
Yes. So we start with product, which would cause us to split all these up. Natural log of 8 plus the natural log of x to the third plus natural log of y squared plus natural log of z to the fourth. And then we do our powers. Natural log of 8 plus 3 times the natural log of x plus 2 natural log of y plus 4 natural log of z. And that's as far as we're going to take it. Which is the same as 32. Interestingly enough, some math programs, PhotoMath, Mathway, some of the others would give you a different answer because it would change the natural log of 8 to 3 times the natural log of 2. It'd break it up further, but no, we don't need to do that. I'm not asking y'all to do that. That is the final answer. Questions on these here with expanding? Are we ready to condense? Now with condensing, we have two main steps. One of them is powers. And if there's a negative with the number, we take it with it. And then we do our product property. So we do our power property, and then our product property. Power, and then product. And then if we need to simplify, we simplify. So we start with 36. So the first thing we're going to do is our power property. We're going to put the powers back as exponents. 6 log of x becomes log x to the 6. Plus, we move the 5 back. Log of y to the 5th. And here we have minus 4, so we take the negative with it, which makes it plus log of 3 to the negative 4th. So that takes care of our product, power property. Now we can move on to product. We have 3 logs being added together. Well, we can rewrite it as a single log with what's inside being
Log of x to the 6 times y to the 5th over 3 to,
right?
3 to the 5th, sorry.
Almost.
Or 3 to the 4th, sorry.
Yes. It doesn't. I put the number in front because it's only one number and it's the standard form. Just put the number in front. Doesn't matter there because when we simplify our 3 to the negative 4th, we can't leave it there because of the negative exponent. We need to make the exponent positive. And to make the exponent positive, we move it from the top of the fraction to the bottom. And just by moving it from the top to the bottom, changes the exponent sign from positive to negative or negative to positive. What is 3 to the 4th? Plug it in. if there is a number with an exponent, plug it into the calculator and see, does it give us a nice number? If it does, reduce it. If it doesn't, leave it. Questions on 36 through 40. Which one do we want to look at next?
37.
Okay. 37, the first thing we're going to do is our powers. So we're going to move the 3 back to the exponent, which gives us log to base 4 of x to the third plus log base 4 of y to the ninth. Didn't have any minuses we had to take back into exponents, so that's kind of nice. And at this point here, we have 2 logarithms being added together. So we can rewrite it as 1 log with what's inside being log base 4 of x to the third, y to the ninth. Now we can only really use these properties if the bases are the same. And for everything we're going to do, the bases are going to be the same when we expand or condense. Questions on 36 or 37? Questions on 38, 39, or 40? Mm-hmm. Well, the first thing we're going to do is our powers. And we move the exponents, or move the numbers back up into exponents. We have log of 2 to the third plus log of x to the fourth plus log of y to the negative third plus log of z to the negative fourth. We're going to take those negatives back up into the exponent. Since we have multiple logs, multiple of the same logs being added together, we can rewrite it as a single log with what's inside being multiplied together. So we have log of 2 to the third, x to the fourth, y to the negative third, z to the negative fourth. So y needs to go to the bottom, z needs to go to the bottom of the fraction, because again, their exponents are negative. 2 to the third is what? 2 to the third is 8. Since again, that is a nice number, we can simplify it to 8. If, again, if it's a nice number, simplify it. Mainly because one, two, three, 4 keystrokes, and it tells you for this here. Just type it in. No, I mean, if you had 19 to the 20th, overflow error. If we said 19, definitely that one. 19th to the 7th, that's not bad. I mean, that we can write that out. 19th to the, definitely not 14th. That's too big. Because it's, put it in scientific form, that times 10 to the 17th. Try plugging a number in. If it gives you the number without a decimal or times 10 to a power, put it in. Questions on this here?
The natural log one would just say natural log would go to 0.
We just say ln. We don't have to put the base with ln. Questions on any of this here? Questions on anything we've done so far? The rest of it is bonus. So if there's one of those that you want to look at, we can. For 41 through 50, find the inverse of each function.
Oh, this is where.
Oh, is the page kind of flipped?
Yep, pages flip, but 41 through 50 is the bonus.
Oh, jeez.
I do have the full video. It will be posted by the end of the day. That does go through all of these.
Oh, this is one where you have to make it like 2 times 2, or something like that. 2 times 2, and then E is whatever.
Switch X and Y, and then we can rewrite this in logarithmic form.
What was that one that you had it?
That was just working through getting there. That we saw we can plug it in.
What was that one where you put, it was like X equals whatever, and then we had to make like 4,
That's
2 times 2, and 2 log base 2 equals like point whatever.
we did that and then found out we could type some of those in.
I should have talked to the homework then. I had one that I could not get over.
I got the